All right, welcome to video 2 of absolute value equations. This one, we start talking about those kind of special weird cases that start to happen here. So let's just go right into an equation. Again, your objective is still, I can solve equations with absolute values. If you're doing the activities and you're getting them right and you're feeling good about it, that's awesome. A little quick note for those people who haven't done this before, because you can redo the activity more than once, you can do the first 3 problems or whatever, hit submit and see how you did, right? It'll tell you if you got them right or wrong, right? If you got them right, that's awesome. Next time you can just copy those back down again and keep on working your way down to see if you're getting it as you go. So, video 2, absolute values alone. And what do we mean by that is we see that we have an equation, we see that we have an absolute value, but what we need to realize here is this absolute value including this -5? And the answer is no. So here is a rule that we're going to start doing. When we did multi-step equations, we talked about simplifying the equation into 2 variables. And if we simplify the equation into simplify the equation into 2 steps. And if we simplify this down, we notice that we have probably around 2 steps. When we do that, we did our lollipop and divide the equation onto 2 sides, right? So I have one side and the other side. And you can only split an absolute value sign if the absolute value sign is alone on one side of the equation. So I look at this side of the equation, I see I have an absolute value, but I also notice on the same side, I have a -5. Before I can split this equation into 2 equations, I have to get the absolute value alone. How do I do that? Well, the way we're going to do this is we're going to take those absolute value signs and pretend that's the variable. That sounds kind of weird, but think of, you know how we circle the variable, underline the coefficient, double underline the constant? Well, we're going to pretend that the absolute value sign is the variable. Because we have to get the absolute values alone before we can split the equation into a positive and a negative, it's kind of like solving an equation. We have to solve for the absolute value like it's an x. So I'm going to circle my absolute value, which means, do I have a coefficient in front of the absolute value? Other than 1? No, so I don't really need to do anything there. But -5 is a constant. That means it's got 2 lines underneath it, right? And how do I get rid of the constant? I have to do the opposite of subtraction, which is going to be the addition property of equalities. And if I do it to one side, I have to do it to the other. So now I've done that. And -5 plus 5, well, that is 0, right? And I don't need to write a 0. And now I bring down the absolute value of x equals, and what's 10 plus 5? 15. And now I say, wait a second, stop. Do I have the absolute value alone? Yes. So that means that I can split this equation, because on a number line, if the absolute value of x could be a positive number, like it could be 15. So this whole thing, if it equaled 15, this would be a true statement. And if this whole thing equaled -15, it could be a true statement. So I write the equation twice, right? X equals 15. And x equals -15. Notice when I write the equation twice, again, I do not write the absolute value signs. They get taken care of. And in this case, as soon as I've done that, I'm like, snap, there's nothing to solve here. I know what my 2 answers are. The 2 answers are either 15 or -15. And if you're at all confused of whether or not that's true, we can go back and substitute it in. The absolute value of 15 minus 5 equals 10. Well, the absolute value of 15 is 15. And I hate that line there. It's making me twitch. Minus 5 equals 10. So I've done the grouping symbols, absolute value. And then 15 minus 5 is 10. Does 10 equal 10? Check. If I do it again, absolute value of -15 minus 5 equals 10. Again, grouping symbols go first. How do I get the absolute value of -15? It's 15. 15 minus 5 equals 10. So -15 minus 5 is 10. 10 equals 10. Guess what? They both work. So these are my 2 answers, but I'm not done. I have one more part of that, which is write down this. Well, we're going to do that in a second. We're going to do we have to write down that x equals absolute value, and which one goes first, positive or negative? Hopefully you're like negative. Thank you, Mr. Nelson. And then positive 15. So x can equal this or that. And then it says, write this down. Treat the absolute value symbols as the variable. That's what I just talked about, right? First solve for the absolute value, then split the equation. Make sure that goes in your note. All right, Mr. Nelson, show us how it's done.
It's something that will help you guys remember to always treat the absolute value as even a variable. You need to get that alone first. Is remember when we simplify, we go through GEMDAS. We go through our grouping symbols, make sure there's everything in our grouping symbols as simple as we can get it. Then we look for exponents. Then we do our multiplication and division, make sure that's all simplified. And then we do all of our addition and our subtraction as well to make sure it's all simplified. But then we go backwards and do SADMEG to help us solve, which means we have to undo our addition and subtraction first. And then we undo our multiplication and division, which there was none here. And then we can undo our exponents, which we're not going to do this year. But then we undo our grouping symbols, which is our our absolute values, right? So we're going to kind of go through that again here. Where's my arrow?
That's SADMEG.
SADMEG. So I'm going to write both of these down. First thing I'm going to do is make sure that both these sides are simplified. I'll tell you now that they are, but I want to take you through that process. When we're simplifying, you should be thinking GEMDAS. GEMDAS, right? Where multiplication and division happen at the same time as you go from left to right, and addition and subtraction also happen at the same time. We've covered this in class. If you missed it, go watch the video. First things first, we're simplifying, we're not solving, which means I don't need a lollipop yet. We're not going to work on both sides of the equation. Looking inside my grouping symbols, is there anything I can do with 2x?
No.
No. Do I have any exponents?
No.
No. Is there any multiplication or division that I can actually do?
No.
Well, I mean, technically there is multiplication here, but I can't do 3 times the absolute value of 2x yet. Okay? And then is there any addition or subtraction that I can do?
No, not
no.
on that side.
Again, I know you might be thinking, well, I can add 23 to both sides. That would be solving. We're just thinking simplifying right now, okay? So we're kind of just all simplified on this side. We are simplified on this side. Now let's go to solving. Remember that solving, if I could write, we need to go to SADMEG.
That's GEMDAS backwards for those of you who have not figured it out yet.
GEMDAS backwards, and then we're going to solve here, which means we need to undo our subtraction and addition first, and then we'll undo our division and multiplication. And something that you'll look at later is how to undo exponents, and then we're going to look at undoing the grouping symbols. In this case, the grouping symbol is the absolute value. That's what we're going to do last. So let's undo our addition and subtraction first. We've already identified that as minus 23, so let's undo that. How do we undo minus 23?
Addition property of equality.
The addition property of equality, but first,
Lollipop, lollipop, oh, lolly, lollipop, lollipop.
Ba-dum, bum, bum. So here we are. We got our minus 23 that we need to get rid of. We're going to use the addition property of equality. Now you could circle the whole absolute value and treat it as your variable, because that's the last thing. We want to get that alone first, and then we'll solve for our x, right? We have our coefficient over here is 3, and our negative 23 is our constant. That's why we're undoing our subtraction and addition first. So minus 23, we're going to get rid of that by our addition property of equality. And then bring everything down. Leaves us with our 3 absolute value, 2x. Negative 23 plus 23?
0.
Is 0. Do I need to write that?
No.
No. 10 plus 23?
33.
Is 33. Do I have any other addition or subtraction that I can undo?
No.
I don't. So we are done with our addition and subtraction. Is there some multiplication and division that I can undo?
Times 3.
We have the times 3 right here. This is 3 times the absolute value. So if we're multiplying by 3, how do we undo the multiplying?
We divide.
We're going to divide both sides. This is the division property of equality. Divide both sides by 3. 3 divided by 3 is?
1.
1, which leaves me with just the
2x, because I don't want to write down 1.
absolute value of 2x. Yeah, we could write the 1, but then it just look funny. Equals 33 divided by 3 is? 11. Okay? Now we've undone our division and multiplication. Now someone might say, well, what about this 2 times x? Remember, that's in our grouping symbols. We're not there yet. So we're done with our division and multiplication so far. There are no exponents, and now we can work with our grouping symbols. Now, how did we undo the absolute value grouping symbol? Well, what we said is that everything in here could either be, well, it says absolute value of 2x is 11. So if this were an 11, the absolute value of 11 would be 11. But if it were negative 11, the absolute value of negative 11 would be 11 as well. This is where we get our 2 equations. So we are going to break this out of the absolute value by saying, well, 2x could be the positive 11, Again, if this were 11, that would be 11 as well, because the absolute value of 11 is 11. But also, if what was inside the absolute value here were negative 11, the absolute value of negative 11 would also be positive 11, which is why we end up with two equations here.
Absolute value has two lines, so I kind of use that as a cheat for myself. 2 lines means 2 equations.
2 lines, 2 equations. And you should have 2 equations, and you should be solving for 2 equations. All right? We have one-step equation here. We're going to start over here on our left-hand side. And get rid of our coefficient. We're solving for x. We need to get rid of the coefficient, so we are going to use the division property of equality. Divide by 2. 2 divided by 2 is 1. Leaves me with just the 1x equals?
I could leave it as 11 over 2.
That's right. 11 over 2 would be just fine. You could also say
5.5.
5.5 or 5 1/2.
Those are correct.
I like improper fractions. They call them improper. It's all lies. So I'm done, right? No, I'm not done. I still have another equation. Is my other answer automatically going to be negative 11 over 2?
No.
No. In this case, it ends up being that way, and I'll show you. But you should always solve it just to make sure, because they're not always just opposites. If one answer is 2, it doesn't make the other one automatically negative 2. You need to solve both equations to get your answers. Same steps here. We are going to try to get x alone. We need to get rid of that coefficient, so we are going to divide by 2 with the division property of equality. Tells me to do that on both sides. Leaves me with x equals negative 11 over 2, or negative 5.5, negative 5.5. Those are both of my solutions, and I should write that in set notation.
Which one's first?
The positive?
No.
No, the negative always goes first because we write our answers from least to greatest.
But Mr. Nelson, what if I decided to write it as a mixed number?
That is fine too. You also could have written 5 and 1/2, negative 5 and 1/2, sorry, and then 5 and 1/2. That's fine.
Is one more right than the other?
Nope, they are both correct. I just prefer. I like improper
As we get to
fractions.
graphing, you're gonna.
All right, next up, Mr. Craig.
Boom, 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 boom. Hey, look at this problem, and I look at this problem. I say, "Oh my gosh, it's divide by 3. It's impossible. I give up. I don't know what to do. End of the world." Well, remember that we have taught GEMDAS that we use to simplify. And we use SADMAG to solve. And so I go, okay, before I start a problem, I always want to see if I can simplify. And so I go, okay, grouping symbols. Well, I see that absolute values are grouping symbols, right? And so can I simplify that? And the answer is no, because I don't know what x is. All right, how about exponents? Well, I don't see any exponents. All right, well, what about multiplication or division? I do see a divide by 3, but if I divide this top by 3, first off, it's in grouping symbols, so I can't. And second off, 2 over 3 wouldn't necessarily be very simplified. Now, some of you might be asking, well, Mr. Craig, I can get rid of that divide by 3 by multiplying both sides by 3. You're right, but the difference is that's not simplifying, that's solving. Because if you do the multiplication property of equalities, that means you're doing it to both sides. That's solving an equation as opposed to simplifying an equation. So that doesn't work into this. So there's no that I can simplify. Let's try to solve. So if I try to solve, again, I'm going to go to SADMAG now, and I say, is there any subtraction or addition I can do? There is some addition, but it's inside the grouping symbols, and the grouping symbols come at the end of SADMAG, right? So I can't do them yet. So then I look over and say, is there any division or multiplication? And I say, oh, there is some division. How do I get rid of divide by 3? Well, the opposite of divide by 3 is multiply by 3. So I'm going to use the multiplication property of equalities. Make sure I do my lollipop, boom, 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 because I want to make sure I have a side here and a side here, because if I do it to one side, I got to do it to the other side. So if I times this side by 3, I'm going to multiply this side by 3. 3 over 3 doesn't make 3 disappear. It just turns it into a 1. And we don't need to write that 1. So we're just going to write the absolute value of x plus 2 equals, what's 5 times 3? Is 15.
Mr. Craig, is 2 plus x the same thing as x plus 2?
Oh my goodness. Good catch. I was testing. Reason why Mr. Craig did that is because Mr. Craig has always written his variables first and his constants second. So as soon as I see that, I'm thinking, oh, associative property of addition says I can flip them around because I want to do my variables before my...
So it's okay?
It's okay, but it makes things confusing. I should leave the problem the way it is. It's just the way my brain works. All right, so now that we've done that, now we're down to exponents. I don't see any exponents. And then finally, grouping symbols. My grouping symbols here, to do the grouping symbols, I need to take the absolute value. The absolute value means I have two lines. This is how I remember it. Two lines means there's two possible solutions. Because all this stuff in here, we'll just call it crud. All this crud in here can equal 50. If it equaled 15, the absolute value of it would be 15. If all this crud in here equaled negative 15, the absolute value of negative 15 would be 15. So there are two possible answers. So I'm going to write this equation twice. Once with it being a positive, because a positive absolute value of 15 would give me 15. And once with it being a negative. It bugs me seeing the x second. All right, now, what do I do now? I solve. Notice again that when I wrote the equation twice, I no longer write the absolute value signs down. So now I'm going to go in here and just do my little solving here. Circle the equal sign, right, and make a lollipop. Circle the variable, underline the coefficient. I mean, there is no coefficient. Well, there is, it's 1, but I don't need to write it down. So I got the constant and underline the constant. And the cool thing about absolute value equations is while the answers won't necessarily be the same, the steps you do are. So I go, okay, how do I get rid of plus 2? Well, according to SADMEG, if I have to get rid of a plus 2, the opposite of plus 2 is subtract 2. So if I subtract 2 to one side, subtraction property of equality says I subtract it from the other side. 2 minus 2 equals 0. That's why I wrote 0, but I don't need to write that down. Drop down the x. And 15 minus 2 is 13. So x can equal 13. And that would give me 13 plus 2 is 15, absolute 15. Or I can subtract 2 from both sides, subtraction property of equality. 2 minus 2 is 0. That leaves me the x. And negative 15 minus 2 gives me negative 17. Back to those people who did the 13 and assume that you have a negative 13, try plugging it into the equation. You'll see that it doesn't work. So if I put negative 17 in here, negative 17 plus 2 is negative 15. The absolute value of negative 15 is 15. So both answers work. Now I just have to put my solution in my answer box. So I'm going to put x equals the set, and I'm going to put negative first because negative comes before a positive, negative 17, comma, positive 13, close set, or my funky chickens. And there's your solution. All right, and that finishes today's video.